Okay, asking about the pipework configuration in hot water cylinders. Sorry about my diagrams, but I've scribbled these together very quickly to make this video. So why do we put the flow in at the top of the coil and the return at the bottom? It's commonly thought that if we put it in the bottom, we'll have the highest rate of heat transfer, as the highest temperature water will meet the coldest water. But that's what they call co-current flow, I think it is, when you look at heat exchangers. Or maybe I'm getting the terminology wrong. Anyway, you want it the other way around. I'll try and look up the correct terminology for it later. But you want to get as much heat out as possible. So basically you want the return to be in the coolest part of the cylinder. And here, obviously, at the bottom of the cylinder, we've got the coolest part, and we can give up as much heat as possible from the coil before it returns back to the boiler. If you're heating a cylinder from the bottom, then obviously as you get to the end, it reduces the amount of heat energy the coil can give up because it's then rising into the warmer water. So I've denoted that here as flow in hot, a return in blue, and here we've got the flow in red, and I've got an intermediate colour to represent a warm return. And you've got to remember that contrary to popular logic, that DT is controlled by the boiler. So if the return is cold on the boiler can put more heat energy into the flow, and this is because the thing that's determining the amount of water here, the amount of energy going in the water here, is actually the flow temperature. So let's say the boiler is maxed out at 82 degrees centigrade flow, but we've got water coming back at 80. Then all the boiler's got to do is raise the water temperature 2 degrees. So the boiler's going to be at the lowest modulation possible in order to put that heat in. But if this return has got a lower temperature, a wider delta T on here, then obviously the boiler's got to work harder to raise that temperature. So we want this return as cold as possible to maximise the heat imparted into the water from the boiler, and to maximise the heat transfer from the coil. As the heat stacks up in our cylinder as well, the point at which this gives up its temperature just moves down the coil to the point where the water at the bottom, this one, so the water comes in, and this sort of heat give up will just move down the cylinder. It will still give up the heat right to the bottom of the cylinder. That's it. I think that's pretty self-explanatory, and why you should always put the flow in at the top of the cylinder. The cylinder does not control the delta T. A lot of people have this argument many times over. The DT is controlled by the boiler. It's the amount of energy put in. If we switch the boiler off, DT will be 0. Doesn't matter what happens here, we'll get a stabilisation of temperature, but DT will be 0. We only get a change in DT with the boiler on, which is absolute proof that DT comes from the boiler.